So today I want to talk about something that affects our daily lives more than we realize. That is the environment of Earth's orbit. Thousands of active satellites constantly orbit our planet, and they provide us essential services from navigation and communication to weather forecasting and scientific discovery. But they share this space with an even larger and faster growing population of debris from old rocket bodies, defunct satellites, and fragments from collisions and tests, etc. Understanding this increasingly crowded and fragile orbital system is very crucial as we continue to rely on and explore space. This infographic provides us three perspectives on situation. On the left, we have a timeline showing the historical growth of different object types since 1957. In the center, we have concentric rings mapping the major orbital regions from low Earth orbit to geostationary orbit, showing the mix of active satellites versus debris in each zone. The central circle represents key spacefaring nations, and on the right, we break down the population by primary purpose or operators, such as commercial or military missions, etc. Looking at the historical view on the left, we can see the number of tracked objects grow dramatically since Sputnik 1 launched in 1957. While active satellites increase, notice a significant contribution from debris sources like rocket bodies and inactive payloads early on. We have key events marked by the annotations, as you can see over here. Events like 2008 Chinese anti-satellite test and Iridium Cosmos collision ended up causing a big jump in the debris population. More recently, the sharp increase in the stream of time over here, this would be caused by the major increase in satellite constellation that have been launched recently, like Starlink and their competitors, Blue Origin, etc. And the bottom brackets represent the total count of active satellites and debris objects at the end of year 2024. The central chart gives us a snapshot of where these objects are. Each ring represents an orbital region. Each icon is an equivalent of about 10 objects. The color is the distribution between active and debris particles. The cyan color represents active satellites, and the red color represents debris particles. You can immediately see that the lower Earth orbit is the most crowded orbit over here. It contains the most objects, both active and debris. In contrast, the geostationary Earth orbit, which is very vital for communication, appears less crowded, but the debris is there almost indefinitely. In middle and heliocentric Earth orbits, tracked number of debris actually outnumbers the active satellites. And the central flags represent the major nations and their share of active satellites. This visualization was created using a weighted Voronoi distribution, where the weight is the number of satellites that are in space and active. The only change that was made to the weights was that United States weight was divided by half because it was just too big and it was taking almost all the space in the circle. And finally, the chart on the right shows that who operates these objects. We see a breakdown by purpose, which is academic or nonprofit, civil government, military, and commercial. These are unknown, probably classified. We can see the red icons again represent the debris, and then the blue icons represent the satellites. Scale is same here. Each icon represents about 10 satellites or 10 objects, and the exact counts are labeled right next to them. A key takeaway here is the surge in active commercial satellites, actually, largely driven by probably the new constellation like Starlink and their competitors as well. However, we see a significant debris contribution across multiple sectors, reflecting legacy hardware and the byproducts of decades of space activity and not being systematically deorbited. So, you might ask, why does all this matter? Why does space crowding matters? This brings us to the Kessler syndrome. In 1978, Donald Kessler, who was a scientist at NASA, warned that orbital collision can create debris, and that would trigger more collisions in a runaway chain reaction. This cascade effect could eventually render vital orbits unusable. Today, with debris already critically cluttering our LEO or lower Earth orbit, the risk is significant. Every object, be it an active or debris, is a potential collision hazard, and that threatens the satellites providing services that we really depend on, such as communications. And it would also jeopardize our access to space in the future. It truly highlights the fragile nature of our orbital ecosystem. So, in conclusion, the visualization highlights several key points. Earth's orbit is increasingly overcrowded, space debris possesses a significant and growing threat, major events have long lasting impacts, and new and large constellations are rapidly changing the environment, particularly in the lower Earth orbit. Although there's a growing awareness and policies being put in place, now now more than ever, I guess the awareness has been more than ever, and the efforts are underway globally to mitigate the debris crisis. However, the question is, are the efforts enough, or do we have to do more? With that, we'll move on to our dashboard. Okay, here's our dashboard. This is the first element of the dashboard. It is an object count throughout time. It is completely interactive, and you could select the type of objects you want to see. The first three are the active objects, and the last, all everything else is the debris objects. You could select, and the legend would appear on the right side of the plot. It shows us what color represents what object. You could also select the type of plot you would like to have. It could be a stacked area, it could be a stacked bar, it could be a line plot. Here's the slider that guides us through the years. This was completely created using IPy widgets, so everything was manually created for the interactive objects, elements. And you could start with time, and it's going to go through time, and it's going to play a timeline of it. You could, at any point, enable or disable anything, basically. I tried to match the color schemes with the infographics. Okay, and now let's move on to the next one. Now, this is an interactive bar chart that shows us the debris that is still in the orbit and the debris that is being deorbited. So throughout the time, as we start our space race, or as humans started our space race, the debris was always being created. It's just like a good chunk of the debris was being deorbited because of the gravitational pull, and a good chunk was not being deorbited because the gravitational pull was not enough to deorbit it, or it would take far too long in number of years, let's say like 500-600 years, to deorbit the debris that exists in the environment if we don't do it manually. So as we can see, a good chunk of debris was deorbited by itself, and a good chunk stayed up there. Now, this was created using Plotly, and yeah, you could slide it along the years and understand at what point how much debris was in the space, or that's the cumulative debris. This is the cumulative debris that has fallen out of space or deorbited itself. Now, okay, and this is our last part of our dashboard, which is, it's a 3D simulation. So the elements are the compliance rate, which is how many satellites being put up in the space. They have a proper plan of being deorbited upon the end of the lifetime, because a lot of the debris that exists right now is basically just satellites that stopped working and they don't have any purpose and they just lined up there doing nothing, being a collision hazard. So if we imagine 100% compliance rate, that every satellite that is being put up now is going to be deorbited at the end of the life cycle, and here's the rate of the satellite growth, and here's the cleanup that we will do per year. So this is a 3D simulator, so you could just put up the numbers and understand how much exactly do we need, the ratio of all these three things, because these are the three factors that will determine the future of space: the compliance rate, the growth of active satellites, and the cleanup per year that we have to do for the existing debris.